project A3, my assigned task was to assign everybody an assignment so nobody feels left out.
Hi, my name is Mohammad Munsur Rohan, and for this project A3 for CodingCrew, I was assigned to create the video and upload it to the YouTube.
Hi, my name is Hayden. For this project, my assigned task is to get the final report ready.
Hi, my name is Hayden Kowalchuk, and my task this time was to set up the GitHub repo and then coordinate team meetings throughout the week.
So for project A3, what I learned was the two types of models, which were the shared memory model and the thread model. I was able to compare it and I saw some main difference in between them. And then the shared memory model shared a common address space, whereas the thread model shared a memory programming that execute and process the task. And also, the thread model was best described as a subroutine.
And with respect with what Vera said, I learned how the parallel programming system, computing system works as a whole in terms of communication and synchronization in between each processes and memory locations and registers and with each other, and with how that goes into performing many tasks out simultaneously to provide maximum efficiency of time.
For this project, what I learned is about parallel programming. When the number of threads cannot evenly divide the number of iterations, the compiler spreads the remainder into threads sequentially. And what's more is that the reduction operand could help us
Just to break down kind of smaller tasks into folded ones. And for me, I'd say on this one, along with what the rest of the team said, the idea of using threads to break problems into smaller chunks, but then also how to come up with a chunk size that makes sense for the given application. And then also on the assembly side of things, how to effectively use memory space and the registers on the Pi, since all the registers we've been using are 32-bit, and how to store things like bytes and half words, which are 16-bit, in memory space and still be able to interact with those.
Also, another thing that we learned was the system on chips, which was an integrated chip that integrates all the component into a single circuit, a single chip, so my bad. So the Raspberry Pi was a really good example of it because it's a system on chip. Literally, it's integrated into a chip.
Exactly.
Yeah. So that is, and the system of chip is way better than the CPU because then we can have different sizes of how we want our models. So that's why the system of chip is better than the CPU motherboard.
So for this project, what I learned from this was how the parallel programming system is implemented into a lot of modern day computer systems to increase the efficiency, which is required in terms of big data, because a lot of the programs nowadays have huge amounts of data that need to be processed, and having a system like a parallel system is much more efficient and preferable, because people nowadays are short on time. A lot of things, we expect things to be faster.
So I'm going to use what I learned from how threads work for the next upcoming project, because the parallel program is more about threads and forking and all of that. So I'm going to use that to build onto what I know and get better at parallel programming.
I'm gonna case study, such as the loop things. I think that will be very useful.
For me, I think the big takeaway for this programming task was really just a different way of thinking, and how instead of having a sequential algorithm where you do step by step by step and then eventually you get to an end, but rather a system where you'd have checkpoints and you could do a bunch of tasks all at the same time and then gather that result and then move on to the next thing, where many of those are working in parallel, and then you gather the result and use that. I think that way of thinking will really be helpful.
Yeah, and exactly. And with that retrospect, it would be beneficial for my career because I believe programs will get faster and faster, and knowing this will make me a better programmer.
Yeah, like how we can crunch more data in less time and still have it be responsive for users.
Right,
definitely.
Exactly.
The worst challenge was trying to figure out a way to bring everybody together in the same time, and how to use our time wisely, and also how to get the tasks done without not being distracted, because everybody have other stuff to do.
Right.
And the best challenge was how I figured out that when we had to use the H and the SH. And I thought we had to use the SH into the shop word, but actually we had to use it to locate the memory location. So the best challenge was me figuring that out after a lot of trying. So it was a relief to finally get it done. So that was the best challenge.
Right.
When you finally compile and it's like
It worked.
Finally did it. Yeah, same thing with me. The workload in general, in terms of coding, took a lot of hours. Especially considering, tasks from other classes that are involved as well, balancing work and school. And also, as soon as you finish one project, there's automatically another project for the next week, So that's probably the most challenging thing, but, I believe that puts us in in a real world situation where projects are continuously piled up on you.
Definitely.
For me, the most challenging part is that I met an error in coding up the assembly file. The sample code gives us is that .s half word, but the correct one is just .h word.
That was so I really wanted to figure that out.
For me, I'm going to echo what Rohan said. Basically, when you have 2 weeks to do a project, you think, oh, that's plenty of time, but then you kind of realize it's closer to a week. And then even in that week, you don't have 7 days to work on it due to other requirements and meetings, work, other classes.
No life.
So I think that's a valuable lesson, though, in that even though you have 2 weeks, you shouldn't put it off because you might be busier that second week or another thing like that. And for me, the best thing was really just playing around with the third parallel programming task, the reduction one, and seeing how that worked, making changes, and then hypothesizing how that will affect the sum at the end, and then just kind of playing with that and really learning how that thread local storage works, and then how they all come together at the end.
And I also like to echo on what Rohan said too. When it was sometime in the week we couldn't meet up because everyone was so busy. So the best thing for us was to just schedule through Slack. So using Slack was and midterms too. So Slack has been really helpful for us to make sure. Oh, we can't make it today because somebody's like, okay, let's do electronic meeting. So it's been really helpful.
And that was your idea to do that electronic meeting, and it worked really well.
It worked really well. Everybody still got their assignment done and everything got done on time. So I guess the communication part is pretty okay.
Props to the team.